Hello students, welcome back. Let's go to section 3, circles. Here's the standard form of the equation of the circle. A circle centered at h, k with radius r can be written as this equation: x minus h total quantity squared plus y minus k quantity squared is equal to r squared. R is the radius and h, k is the center. Here's a visualization. From the center h, k, we have, this is randomized and part of this printout is cut off. Let's run it again. Okay, I like this picture a little bit better. This time I have entire x, y visible. Alright, the distance between the point on the circle x, y and the distance to the center h, k remains the same. The radius r. Actually, the definition of the circle is like this. It's a set of points x, y whose distance from the center h, k stays the same, r the radius. And it comes from the distance formula. The distance between x, y and h, k is equal to r, so by the distance formula, the square root is equal to r, and square both sides, and we get this equation here. A special case when h, k, the center is the origin 0, 0, and the radius is 1, then we get x squared plus y squared is equal to 1, and that's called the unit circle. And this expression is important in Math 1600 trigonometry. At this moment, the unit circle is nothing more than a special case of the standard form where h, k is 0, 0, r is 1. I shouldn't erase this. Okay, from here, the standard form, I can break up the parentheses and take the like terms together and simplify. If I do that, I'm going to get this kind of form, which is often called a general form. From here, break up the parentheses. By complete square formula, we get this from the first square and this from the second square. And then flip this r squared to the other side, we get minus r squared is equal to 0 like this. And then take the like terms together, we get this kind of form. Please note that we have to have same coefficient, x squared plus y squared, or multiply the same number to each term here and get capital AX squared plus capital AY squared. If these two coefficients are different, then that's not a circle. It's very, very important that these two numbers are the same. Okay, alright, let's go to some example problems. Find the standard equation of the circle centered at -2, 1 that runs through the point 3, 2. Let's see, here is the standard equation, and then the center point is given explicitly, -2, 1. So this one is going to be -2, and this is going to be 1. Of course, nobody writes like this. X minus of -2, we write as x plus 2. And this one, y minus 1. Okay, so far so good. So if we find the radius, I'm through. How do we find the radius? Think about it. Stop the playback and think about it. Centered at -2, 1, and then it runs through 3, 2. So is that enough information to tell you the radius? Yes, it should. What's the radius? That's the radius, distance from the center to any point on the circle. And the point on the circle is given as 3, 2. So yes, you can find the radius from here. So what is the radius? R is equal to square root of the distance formula, minus 2 minus 3 squared, the difference of x coordinate, 1 minus 2 squared, the difference of y coordinate. But then again, I don't have to take square root and then square again. So it's going to be easier if I just square both sides and then write it without the square root. This is not too difficult a computation. Negative 2 minus 3, okay, negative 5 squared, so that's 25. And then 1 minus 2 is negative 1 squared, so it's 1, so that's 26. So looks like this whole thing is, let me just rewrite once more. So we're going to get this. Is everybody happy with this computation? I didn't even have to draw. Okay, here we go. The solution. The center is there. The radius, we use the distance formula. That's 26. Find the standard equation of the circle, center and radius, but I did not complete the problem here. Okay, x plus 2 squared plus y minus 1 squared is 20. Oh, I do have it here. What was I thinking? I do have the answer here. Okay, here's a visualization. Centered at negative 2, 1 and running through 3, 2. And this distance we calculated, square root of 26. Find all intercept of the circle of the previous problem. Intercept problems are always interesting. They're always important, at least to a certain degree. Let's see, do we have a visualization first? Okay, that's a circle. And then running through the point 3, 2 right here, but that's not that important. We are interested in these 2 red points and those 2 green points, x-intercepts and y-intercepts. Okay, all right. X-intercepts are estimated as about -7 and +3. Y-intercepts are a little bit harder. Looks like they are not integer values, but we don't need all those. Okay, here, and then we are looking for x-intercepts. Okay. What's the typical technique? Y is equal to 0 and looking for x value. That's going to give me the x-intercept. And then after that's done, I'm going to plug in x equal to 0 and looking for y-intercept. Let me color code this one in red and that one in green so that you can see better association with these 4 points there. Okay, how do we handle the first half of the problem? Plug in y is equal to 0. Okay, here we go. And y is equal to 0, so right, there you go. X plus 1, x plus 2, excuse me, squared plus 1 is equal to 26. X plus 2 squared is equal to 25. I could have broken up this complete square too and then factor it back or take the quadratic formula, but what's the point? It's already complete square. Complete square equal to something, and then I'm going to take the square root here. Is equal to plus or minus square root of 25. What's square root of 25? There. Square root of 25 is 5. So we have x plus 2 is equal to -5, in which case x is equal to -7, or x plus 2 is equal to +5, in which case x is equal to 3, and there you go. This and that are these two red points. Is there any way I can keep everything in the same viewing window? I'll have to sacrifice the size of this picture. Okay, here we go. So that is the x-intercept. Okay, now let's go to the y-intercept. That's going to be a little bit more challenging because, as you can see, these are not integer values. So the factorization is not going to be really neat. And it's not likely to be a monic polynomial you're going to get, or even worse. Let's see. Let's go ahead and do that. Plug in x equals to 0 and looking for y. So plugging x equal to 0. So what do you have? 2 squared, so 4 plus y minus 1 total quantity squared is equal to 26. So y minus 1 total quantity squared is 26 minus 4. How's that? 26 minus 4 is 22. Therefore, y minus 1 is plus or minus square root of what? 22. And there you go. Square root of 22. That's not a square number, so you're not going to get some simple integer answer or even rational answer. So you're going to get y is equal to 1 plus square root of 22, which is approximately equal to, okay, I can punch in the calculator, but so yeah, okay, this y equals 1 minus square root of 22, which is approximately equal to, let's see, negative 3.69 something. Okay, so there goes one's y-intercept. That's the other y-intercept, and they're represented as green dots here. Negative 3.69 or so over here, and 5.69 or so over there. Does it make sense? It should. What did I do in this notebook here? Same thing. Same thing. Okay, we just went through the standard form and intercepts. Let's talk about the other example in a separate video. It's going to be longer.